Okay, so this is the webinar, How to Solve Technical Issues in Large SAS Environments with the BOMSCA ESM. And I just wanted to thank you very much for joining, for taking the time today. My name is Al Cordo. I'm the Chief Data Officer for Qualix. And we at Qualix are a longtime SAS partner with headquarters in Bay Harbor Island, Florida. We didn't get any snow today here in Florida, fortunately. You may sympathize with that. I am a longtime SAS user and have worked for 13 years at SAS. And during my time at SAS, I reported to the SAS CEO, Dr. Goodnight, which many of you probably know since we are all SAS users, I believe. So let me just go ahead and get started with this session. And the first thing is we had set aside time today, 1 till 2, to go over a little bit of introductions. Then we have a great demo. For questions and answers, I would suggest that you type in the chat. So we'll take those. So that way we can cover all the material that we have today. And then certainly the recording will be available. So we'll reach out, send the recording, and of course establish any additional conversations that you may have about your particular situation. So let's just think about the reason that folks join and register for this webinar. Is number one is business users are being granted a lot of processing power, but there isn't a mechanism by which they can understand their resource consumption or control the impact they have their efforts on their colleagues. And that's not only for the business users, but also the IT departments in our conversations understand and need that. So one question is, how do I get the full benefit of the analytic platform and at the same time that I understand what is going on? And that's where ESM comes to play a role. So BOMSCA, which is a SAS alliance partner, built a product around that, and their objective is to keep folks like us, data scientists, very happy. And so they have monitoring tools to keep the platforms, analytic platforms, working, making sure that everybody plays nicely together and that we understand what's going on. We know that that's always very helpful. So there is this important possibility of us understanding what's going on that wasn't available before. Us, Qualix, we're an integrator. We've been a SAS partner for many years now, since 1995, and we have multiple offices. So we are working together with BOMSCA to make sure that ESM gets used in North America. So with us today is Nick Markovic, Nicholas Markovic, and Nick is the CTO and founder of BOMSCA. And so he's an ex-SAS person. He worked at the UK, and he's somebody that specializes in performance tuning and the root cause analysis. This is the pain point for SAS data scientists and SAS administrators as to how do I do that? How do I get the information that I need to do performance tuning? And Nick comes with a huge background in professional services. So he spent a lot of time with clients and he understands the nature of the workloads and the performance issues that happen. So Nick is really a great presenter for that. So I'm going to turn it over without further ado. I'm going to turn it over to Nick so he can tell us more about ESM.
Okay, let me just share my screen. Hello. Okay, so hi, I'm Nick. I started BOMSCA too long ago now, 6-7 years ago, maybe 8 years ago. And one of the first things I did when I left SAS, when I used to work for SAS, my role was that of somebody who goes and troubleshoots highly stressed SAS environments. So these are environments that have kind of been installed, been used for maybe a year or two. They've become so popular in their use because, let's face it, that's what always tends to happen to SAS. They've become so popular that they've gotten hundreds and hundreds of users, and these users have started to depend on these platforms to do their jobs day to day. And inevitably what happens is eventually users start to compete for resource. As the data grows, as the number of users grows, users start to compete for resource, and when users start to compete, they start to misbehave. They start to run things twice, or do similar things because they can't see what's going on their platform. They can't see what their own footprint is, and they have no way of understanding what it is that was causing their the performance issues that they themselves were seeing. So what I did when I left SAS, when I set up this company and pulled it together, was the first product that we built was what you see in front of you now, hopefully, ESM. And what ESM is it's a tool and a feedback mechanism that allows end users, business users, to understand how complex what they're doing is computationally, how much resource it's taking up, and when it's likely to finish. And if it's running slowly, it lets them know that it's running, albeit slowly, and lets them actually see why it might be running slowly. So it might be that when they ran their code yesterday, the node that they were running on was empty, but today's grid node has another couple of users that are running some really resource-intensive stuff. And the idea being, when those users do understand that that's the situation, they don't do things like restart their enterprise guide sessions because they think it's crashed, or they don't try and run things twice, or they don't try and get quite aggressive about how with their behaviors. So this is ESM. It's what ESM does is it picks up every single piece of activity, every single session, and that's why it's called the Enterprise Session Monitor. Every single session that gets spawned by SAS server side. So that goes for workspace sessions, one of which you're seeing here. It goes for stored process sessions, so we've got our multi-bridge sessions. It goes for pooled workspace sessions, batch jobs, CAS, laser servers, CAS sessions, pretty much anything that is an analytical, well, RStudio, Python, Jupyter Notebooks, anything that is computationally intensive, which is the nature of these analytic workloads, is picked up by ESM, and it is monitored and displayed to users. And what this does is a couple of things. It allows us to more easily travel back in time to understand what it is that happened maybe when our batch fell over at 3 in the morning. And it also gives users that feedback mechanism that I was talking about earlier, that allows them to actually behave responsibly and self-regulate and understand why something is happening. And the thing is, when a user understands why something is happening, they're a lot happier and they behave differently when they're just when they don't. So what I'm going to do is I'm going to sign on to SAS Studio on one of our nodes, and as I'm signing on, you'll see that, I don't know if I click that, no, not very good at clicking. As I sign on, you'll see that the JVM that's being monitored, so this is the web server that's serving our instance of SAS Studio. The JVM does a bit of work. Now's a good time, I guess, to explain the metrics here. So up here, you will always see the selected session, the session in question, and the red line here will be the amount of CPU that session is using in real time. The orange line is the memory, and then the second orange line is the virtual memory, so kind of maps files and stuff. It also monitors the disk throughput that's generated by that session. So these tiny blue bars here that you can't quite see, they are the JVM reading, the application of the disk in order to serve up SAS Studio. And then its counterpart session down here is the server that this session is running on. So like I said earlier, the purpose of this view is to allow the end user to be able to contrast how much their own code is working successfully versus how busy that node is, which in this case is not very busy. But It's a JVM, not the best example, but so we now have our workspace session because I signed on as Gym Demo, and what happens is SAS Studio starts a couple of sessions, and here is my workspace session that I've started. What I can now do is run some code. As I run that code, some workload will be put on the session. You can see that there's not a massive delay. I can see that my piece of code that I ran hit the disks at 58 megaseconds for a while, and it printed a label, which is the mechanism I have for identifying the varying steps in my code, so I can look at my graph and understand which part of the graph correlates to which part of my code. So that's kind of the basic idea of ESM. All data is collected for all sessions and all processes. Users themselves can set up a user filter. So if I'm called Gym Demo, I can set up a user filter here, and then I can go back to my front end, and I can say I'm only interested to see the bits that I have actually spawned off. So this is my workload as a user. I know I now have 3 sessions, and I know about these first 2 because I've just started it, but there's this third session I'm not sure what it does. So what I can then do is go back a couple of times and see what it was that it last did. And what I can see here is that I ran some code. So let's have a look at the breakdown for that time span. I ran some code, and this was code in Enterprise Guide, which you should be able to see here. So hopefully. What my code did is first it ran the filter and sort step. So this is an automatic annotation. So with Enterprise Guide projects, ESM can be configured to just pick up what task it is that it's monitoring, which is quite useful. My code ran, and these blue bars started going up. And these blue bars are periodic measurements of my SAS work size. So I, as a user, can see how big a SAS work I'm creating and which of those steps it is that's creating that SAS work. If I turn that off, I can also see the throughput generated by this code. And this first step is generating 723 meg a second of disk write, while using up 95% CPU, which is very inefficient as far as SAS code goes. This second step is using a gigasecond of read speed, while using 78% of CPU. Again, it's quite inefficient, but it's an example of the kind of computationally simple code that can be produced with really wide tables with Enterprise Guide. It's just the simplest thing I could drag together. But I can see, conversely, on the node itself, how the disks behaved and how the network cards behaved during that time. And I, as an end user, can understand exactly what the footprint is of my code and how computationally complex it is. In this case, not very, therefore it needs optimizing. Now, say I've got disconnected from this session. Say Enterprise Guide has crashed, or I closed my laptop and it switched from Ethernet to Wi-Fi, or there's a routing error in my network, or any number of incidents that can happen in enterprise environments that can cause you to get disconnected from your session. What I can do as Gym Demo, if I'm responsible and my admin has deemed me to be a privileged user, he can add me in here and say, Hadley 2, 1, 2, 3. I've just added Hadley as a privileged user as my boss. Hadley's also on the webcast, and he has Gym Demo on his team. Because Hadley has Gym Demo on his team, Gym Demo can put his hand up and say, "Hey Hadley, I think I've got a zombie session over here. I don't know what to do with it, but it seems to be growing in SAS work, or it might be causing other issues. Can you just clean it up for me?" What Hadley can do is come in here and say, "Okay, I'll force terminate that process. I'll say Hadley 2, which is my login, and I'll say Hadley 2, 1, 2, 3, and I won't remember the password I just gave him." So, yes, Nick asked me to kill this session. This request now gets submitted. I did forget the password I just gave Hadley. I must have typed it in wrong. This request gets submitted, and what happens is through the ESM front end users are able to self-regulate their disconnected sessions, their orphan sessions, any code that they write that might have blocked, so Cartesian joins, anything that they suspect is wasted processing, they're able to clean up through this interface without being granted any shell access. So without being granted any system level access to the remote nodes. All they need is a login within ESM, and they need to have a, once that happens, they go into the audit history of other users, plenty demo users who have requested for a process to be terminated. Now, much like these live sessions, ESM also does a lot to performance profile jobs, because batch processing and batch optimization is a very big part of anyone's estate. So I ran a couple of jobs earlier on our AWS-based grid. It's called shorts test. So when I search for a job, I get the full history of every time that job was run. So this has been run a few times since September. My most recent run of it was this afternoon, half an hour ago. When I click on that, I get the full profile from a performance perspective for that job. You'll notice I also get little flags that tell me when errors and warnings occurred during the lifetime of that job. So ESM scans all log files in real time within a second of the blocks being written to the log files. So it's actually scanning them from cache rather than having any disk overhead. But errors are detected, and errors are overlaid over our performance data so that we can, at a glance, see whether a job did have errors or it didn't, or if it had warnings, and if it failed, why it failed. And if that's not enough, clicking on one of these errors allows me to use the same login that I just gave Hadley, apart from I can't remember the password, to retrieve the log file for that particular job from the server. And also, you'll notice highlight the exact error that I hit, so it'll actually navigate its way through the file to the error that you click on. Which saves a bit of time. So in terms of root cause analysis, it can save a bit of time, save you digging through and associating files and stuff. Now, what's interesting about this particular job is that it's a grid job. So if I search for linked sessions that were linked to this grid job, it was actually a SAS G-sub submitted job earlier. What this will show me is it will show me that there were 3 sessions involved in this grid job. One of them ran on Dev2 GCOM 2, and 2 of them ran on Dev2 GCOM 1. The first one, blue one, that ran on Dev2 GCOM 2, used a bit of CPU very sporadically. Well, I can go into why that is in a minute, and grew a SAS work for that session. And then the other 2 sessions that kind of did the same thing, alternated and was split between the other 2 nodes. And if I suspect that either of these was underperforming, I can always click on it and I can get the profile of that exact subsession for the grid. Now, what's interesting here, and it's a good time to dig into the node level metrics. What's interesting is that you'll notice that there's very little CPU being used efficiently up here. However, if you look at the node seems saturated. And I'll just turn off the cache for the time being. So this gray area up here is the file system cache. It's quite an advanced metric. We can talk about that in a while. If I turn off the cache and I turn off the memory because they're not relevant, you'll notice that there's the CPU measurement here is red, but you'll notice the gray area underneath this CPU measurement. And what that is the percentage, the proportion of that time that was wasted due to IO wait. So this is when the processor was waiting for the IO subsystem to come back with data so that it can feed it back and actually use the data to be processed by the SAS job. Almost all of the time here is being spent waiting, and whenever it's not, you'll notice that there are these sporadic spikes where our job actually gets to do some work. The reason why it's being spent waiting is because SAS work on this node is a shared NFS-based file system, and ultimately, it's too slow for our process. So what's happening is the kernel is actually filling up the buffer. So if I turn all this other stuff off for the time being, the kernel is filling up the buffer, and every time it fills up the buffer, it allows the job to fill it up, and then it purges it to disk. Whenever it purges it to NFS, everything else is blocked. And every time this buffer fills up, there's kind of a fill up and purge cycle that happens here. And this is a good indicator, especially on AWS, because this is a cloud-based grid deployment. It's a good indicator of either disks that are too slow or network devices that are too slow, and a good candidate for kernel level tuning of how those I/O elevators can be tuned to take better advantage of the storage that is available underneath. Now, I have some actual production data, which is really useful. I'm really happy with, from a couple of years ago, from one of our clients who were doing a grid migration, and they had a very performant Windows-based grids. Windows-based single server installation, and they moved to a grid, and they were having some performance issues, and their job started failing. And what I like about this data is it gives us an end-to-end picture of how ESM can be used to diagnose both simple basic issues and kind of deep infrastructural issues that need to be addressed. So if I know that a job failed because they were told the job failed, so they came in here, they said, okay, show me all the jobs that have failed recently. They had some jobs that failed every hour, and they were very short jobs, so they weren't concerned about those. But there are these two in the middle that did fail, and they wanted to understand why. So you can open the historical data from one of these jobs just by clicking on it. And you can see again that this job had some warnings at the beginning, and they ran fine. And then its SAS work started growing about 6 minutes in, grew, and at the end, their job failed. And it failed because a lock was not available for table DGTL something. The lock was held by process 21201, of which they'd by this point lost track of because it was in the middle of their batch, and they, it was a while ago. So with ESM, what they did is they selected a recent time span, and they came in here and they hit the graph button. Also, you'll notice this is a much older version of ESM, so it's functionally the icons are old, but they came in here, they hit the graph button, and that gave them a breakdown of every other session or job that was running for the time span they just selected. And what they could do here is sort by PID, say 21201, and say, oh, there you are, workspace user UI something. Why did you lock our table? You seem to have locked our table in EG. Why did you do that? That's naughty. You've brought down our entire batch. And what this user did is they said, well, look, I do this every morning. It's not me that's broken the batch, it's your batch that's broken, because I come in every morning at 9 o'clock and my data is here. Why was your data not here? So what they could do is go into ESM and click this job history button for this job, and they could see that this job was running at 7 in the morning for ages, and then every weekend when they migrated more jobs onto their new platform, it was getting pushed forward because of dependencies later and later, until the first point that it crossed the 9 o'clock barrier and failed. So it wasn't the user's fault, it was the batch's fault. But why did this keep happening? Now what they could do is go back and look at the time series profile, the really detailed data, the highly detailed performance data for this job, and they could see that most of the time this job ran perfectly fine. It was getting 70-80% CPU. That's perfectly reasonable, but it had these massive troughs where there seemed to be some kind of destructive interference being causing these dips, these starvations in resource. And what they could then do is say, well, maybe that's another job or another session that's just using the same resource and therefore causing this interference. Let's have a look if it's another user. Again, go into this graph view. And they could then cycle through each of the other jobs or sessions that was running during that time and see whether they were suffering from the same kind of problems or whether they were the ones causing the problems. Now, this batch job, which it ran alongside, seems to be suffering in exactly the same way. So the dips in CPU are almost the same, apart from this kind of piece here where there is some more CPU being used, but ultimately this job isn't the problem, it's also suffering from the same problem. There's the workspace session, it's not really doing much. There's another workspace session, again, maybe using a bit more CPU, but suffering from the same issues in this specific part. So you can see that it's being starved of CPU in exactly the same time periods. But the last job in this list doesn't seem to have any of those issues. And this leads you to ask the question why, and the answer being that all these other jobs seem to have SAS work that's rising. So this one started with 27 gig SAS work and finished at 92 gig, whereas this one is using 92 meg of SAS work, which means that it's actually the SAS work that's the issue, the speed of the SAS work probably. So if you see that this job that doesn't use SAS work completely disappears when you take the breakdown back to SAS work. So what we could then do is come back here and look at our device level metrics to identify whether it was the SAS work disks that were causing issues. Now, this system was architected to use 400 meg of throughput per node, because that's what the calculations from SAS came back as, because it was, I think it was 4 cores a piece or something. And sure enough, it was using 480 mega a second disk read, and it was writing at 400 meg or so a second as well. So none of the performance tests, the I/O tests that were used to validate the grid node were, pick this up. But if you have a look at the patterns from the disk device itself, it looks like every time this disk writes, there's a massive wait. So there's a massive delay in getting the data to the actual job. And I've seen this pattern before, and we were able to very easily identify that the disks had been misconfigured to be mirrored rather than striped, because I think in that instance the configuration for the metadata server for the new environment was copied across all the grid nodes, and the other grid nodes didn't need the resilience of the SAS work directory and metadata. But anyway, I think it's a great example of how you can start with a very simple problem of, oh, our job failed. Oh, why did it fail? It failed because there was a table that was locked. Who held that table locked? Let's open it and have a look at who has that 21201. We instantly know who the user was. Now that we know the context around it and we know that it's not the user's fault, we can go back and reinvestigate the performance patterns that that job exhibits, and then understand what the issues were in the underlying infrastructure in kind of the same few minutes worth of investigation. I think that's a really nice way of showing off the essence and the power of what ESM is capable of doing, not to just SAS, but to general analytic environments, because analytic processing is what this is. It just happens to be that SAS was the first one there by a decade or so. But all of the new tooling also exhibits this behavior, some of it even worse so. So R is very memory intensive and a bit more destructive. And it's this same issue of being able to understand heavy workloads from a business and job workloads, a logical context perspective that ESM is great at. Now, I think we're running out of time a little bit, but the last thing I like to show is that the chargeback capacity of ESM. So all of the area under these graphs is calculated into cost items, and the information that we know about the jobs and the users is it's attributed to those cost items as the user and the job name. What we can then do is open a classification interface that allows us to put those cost items into buckets. So what we can do is we can say, okay, so we know that job ran in January. I think if we want to have a look at that entire job flow and how it behaved, if I go back to January 2017, it's quite an old flow. I can actually go through and have a look at what the rest of that batch flow looked like and the other jobs that were there, and you can see the clusters that are each of the actual flows and the dependencies between those flows and the jobs on the critical path between those flows. So these are the jobs that are top candidates for actually being optimized to improve the overall runtime of the batch. But we can get into that another time. But our data is in January last year. So if I say I want to understand what my costs were like between the 1st of January 2017 and the 31st of March, and I say I want a 90% confidence, what ESM will do is it'll go away and come back and tell me each of the job items that I need to classify into a cost bucket in order to fully understand how the distribution of cost should be assigned for that quarter, which means that, as a GPFS department, I'll delete that, which means that I can go in here and say one of my departments was batch, so we can say that's the LSF guys. One of my departments was Lev 1 or users start with UI or whatever, and one of my departments will have been system stuff, and one of them will be, that's fine for now. So if I open these buckets, what I can then do is go through my jobs and start to put them into cost buckets. So live, I know that's a batch job, that can go into batch. We've already classified 23% of our overall workload for that time period, because that's obviously a very expensive job. MMFSD is the second biggest thing there. That's because GPFS is awful at resource use. So that can go into system. In fact, ESM agent can go into system because ESM agent used 0.5%. What else? GPFS. So anything that starts with GPFS, that can go into system, and you get the idea. So anyone that's using Lev 1 maybe, whose name starts with UI, all of those guys, they can go into the UI here, and suddenly we've classified 56% of our workload. The idea being proving environment. The idea being that once you've gone through and put this criteria down as to which user and job name patterns belong to which department, you can produce a report that says, okay, so this is how your cost was split between your departments for this time period that you're trying to attribute cost to. And if no one believes you, then you can print the report, and they can, you can put it on their desk and they can go through it with a highlighter and complain. But what's measured is measured, and it's fact, and it's there. So these are the benefits of having that level of data within an analytic environment, both from a performance tuning perspective, from a user's understanding what they're doing perspective, and from a kind of infrastructure tuning perspective. And that's what ESM does. It brings all those things together and allows your analytic environments to operate efficiently and allows you to get the most out of your investment in analytics. So I'll back over to you. Anyone has any questions?
Thank
okay,
you.
I see James.
Yep,
okay.
Yeah, we got a question from James, and it's Nick, and it's about, can you talk about whether is the tool limited to Unix and Linux only, or?
Okay, no. So the tool works on Windows. So half the data you just saw was on Windows. It works on AIX, although AIX is an interesting beast when it comes to performance tuning. It works on Solaris, HPUX, Linux. It works on Mac as well, but I mean SAS doesn't run on Mac, but Python and R do. So it works on most major platforms apart from mainframe, because mainframes are different altogether. So, and you can have mixed environments. So you can have agents on whatever platform, they can all report to a single ESM server, and you can see the data in the same way.
Great. There's another question, Nick, about essentially when we looked at the privileged user in, notice the logs. Can you talk a little bit about the logging for individuals and so on? What is the extent of that?
So privileged users it can be integrated with AD, and you can tie it down so users can only see their own logs and terminate their own sessions. But ultimately, privileged user, the two things that you need to give system level access to end users for generally are accessing job logs and terminating sessions. And I've been to too many financial institutions, incidentally, that are happy, or not happy, but are forced into giving end users shell level access and telling them, here you go, this is how you use the top command, and here is sudo kill. Figure it out, kill your own sessions because we're tired of it, kind of thing. And it's the same thing with retrieving job logs. So the privileged users are the ones that can do anything but view data within ESM, which includes retrieving logs and doing session management. And all of their activity is audited. And as you saw in the admin settings here, so there's an audit log for every time a log file is opened. So that was me opening a couple of those logs, and every time a session is terminated.
Okay, and so here we're looking at the log of the SAS admin user as it's going through the different files.
Yes. Every time the SAS ADM user was used to terminate a session, here is a list. And this is when Alan did 150 gigs worth of SAS work. We also use this operationally for our dev systems. We need to be a bit more vigilant with the quality of our comments. But yeah, so any user that's given privileged access is able to either do sessions or logs, and there is a filter that you can apply that dictates which user sessions they can terminate. So they, you can have users that you can paste entire teams worth of spreadsheets in here. Yes, James, it is for everything. Yeah, you can either paste lists of users in here, or you can integrate it with AD. And I saw a question earlier about VIA. So we've been working with R&D very closely, SAS R&D, to make sure that this runs very nicely on VIA, and I'm really impressed with how VIA runs actually. So I think I might have a session that I can use. So there we go. So if we run Paul Kent data again, there's some data that just generates some workload, some artificial workload that we use for performance benchmark testing stuff. If I run that again, what we should be able to see in my live view on my session 71 is the individual actions as they happen on our head node, and then subsequently the actual distribution of those actions across the other nodes. So if I go to the last time I ran some actions, when I click this last tag button, what that will give me is, if I look at the linked session search, I'll be able to see exactly what the other sub-sessions, so my worker threads were doing on the other sessions, and I'll see what each of the actions was doing here. So it's very well integrated with VIA. Glad you think so, James.
Could you also comment? Thank you for the comment on the awesome, yeah. So could you please comment on the non-SAS analytic use of ESM?
So yeah, so we have a couple of clients who are mixing their R Studio and their SAS estate, and are finding R Studio to be even more problematic because the capacity on individual servers, because everything is done in memory and that memory isn't shared, unlike CASLibs, for example. They're having real issues with their systems dumping out into swap and just completely grinding to halt, just because there is very little regulation when it comes to managing the open source toolset. And what they do with ESM is the same as what they do with their SAS users. They say, here you go, this is how computationally expensive what you're doing is, this is how much memory you're using, this is how much headroom you have on the server that you're currently using. So you're a programmer, you might be a business user, but you're a programmer, you understand this stuff, so knock yourself out and behave nicely. And since they did that, they've massively stabilized their RStudio estate as well. I mean, the problem is the same. The problem of multi-user environments that grant individual analysts massive amounts of power is the same, that the analysts need a feedback loop that allows them to actually do to be responsible and self-regulate.
Great. Well, Nick, thank you so much. I mean, I think it was a really good conversation, great demo. I'm going to turn off the recording so that we can also share with others that didn't have the benefit of making it today. Certainly follow up with them and folks here. Thank you so again very much, Nick, and everybody who participated in this webinar. Thanks again.
Thanks, guys.
Bye. Very
glad you liked it. See you.
Take care.